Class, today we're working on section 11.4, arithmetic series. So we're moving back and working with arithmetic sequences. It's just that we're now working with series. So if you would take a moment and work through the first 6 check skills, and then we'll show what those look like, and hopefully we'll be able to move on quickly. Alright, you can check your work now against mine. The first one is just adding, so we end up with 25. The second one, if we add those up, we end up with a negative 42. And we'll find better or more efficient ways to do this, especially once our series gets a little bit longer. Now I ask you to write the explicit formula for each sequence. So if you recall, our explicit formula is right here in this form. A sub n equals a sub 1 plus quantity n minus 1 times the common difference. So for number 3, our first term is 4, so that's going to be our first spot there, plus n minus 1, our common difference is 2. If I simplify that, I end up with a sub n equals 2n plus 2. The fourth one, our first term is 1, our common difference is 3, so I can again just plug it into the formula. Simplify that, 3n minus 2. The fifth one, the first term is negative 17. We have a common difference of negative 6. I'm going to distribute the negative 6 through and then simplify. I get negative 6n minus 23. And the last one, a sub n equals 10 plus n minus 1. The common difference is negative 9. Simplifying, negative 9n plus 9. Now we're going to move into the lesson. This might look a little bit different than what you have on your page, and that's okay. We're not going to do the investigation arithmetic series. We're just going to look at a couple problems that I'm giving you here. I'm wanting to know the series, the sum of all of these numbers. 1, 2, 3, 4, all the way to 100. And I want to know, if I add all of them up, what is my final summation? Well, we could spend the time just adding all these up. But a more convenient or more efficient way would be to just look at these in pairs. So if I look at the first and last term, I get 101. The second and the second to last term, if I add those, again I get 101. The number 3 plus 98, again I get 101. And I could do this all the way up until I get to 50 and 51. I would have 50 terms to add, so I'd have 50, they all add up to 101. All I would have to do is multiply them and get 5050. A very quick way to find the summation of that sequence. So we could do the same thing if I had a smaller group. 5, 10, 15, 20, 25, 30. Instead of adding them up, and I know it wouldn't be difficult to do that, but I could look at it the same way. 5 plus 5 and 30 is 35. 10 and 25 is 35. And then finally 15 and 20. I get 35, that's the groups of 3. 3 times 35 is 105. Alright, now we're going to look at some definition of series. A series is the expression for the sum of the terms of a sequence. Example 1 says, use the finite sequence 5, 9, 13, 17, 21, 25, 29, and write the related series, and then evaluate the series. Well, the series simply means we are going to sum all of the values, all of the terms in our sequence. So we will add those up and we'll make it look like this. 5 plus 9 plus 13 plus 17 plus 21 plus 25 plus 29. Summing those up, we end up with 119. This whole summation is what we call a series. So check understanding, rate the related series, and evaluate the series, and then we'll check back with you in a moment. The series for this sequence would look something like this. 0.3 plus 0.6 plus 0.9 plus 1.2 plus 1.5, and that would sum to be 4.5. B, the series here, would simply be 100 plus 125 plus 150 plus 175 plus 200. If I add that up, I would get 750. The term arithmetic series is simply the sum of the terms of an arithmetic sequence. So we've just done that. We've taken the sum of the terms of the arithmetic sequence. That's what we call an arithmetic series. We have a formula to find the sum of a finite arithmetic series. It is important to notice that we have the word finite, which means we just have a set number of values we're going to be working with. The formula is S sub n equals n over 2 times the quantity a sub 1 plus a sub n. So in order to know this this series, the sum of this series, we have to know a sub 1, the first term, we have to know a sub n, the nth term, and we have to know n, how many terms there are in the series. Let's look at this example 2. A staircase uses same size cement blocks arranged 4 across as shown below. Find the total number of blocks in the staircase. So if I just look at this sequence, we can quickly see that my sequence looks like 4, 8, 12, 16, and 20. 4, 8, 12, 16, 20. The series then would simply be the summation of those 4 plus 8 plus 12 plus 16 plus 20. Now if I want to find the sum, I've got 5 different terms there. So I'm going to say S sub 5, and I've got n is 5, so I'm going to have 5 over 2 according to my formula. The first term is 4, the last term is 20, so I will just take those 5 halves times 24. I can cancel the 2 and the 24, so I'm going to have 5 times 12, and the sum of those, of that sequence or the series, is 60. Now we're going to move into objective 11.4.2. I think this is easy enough that we can do both of these objectives on the same in the same session. The word limits. It is the least and greatest integral values of n. We have a sigma, looks kind of like an E, but it's a Greek letter sigma, and it means to add or to find the summation. Example 3 says, use the summation notation to write a series 8 plus 16 plus 24 for 50 terms. So to begin with, let's look at the sigma notation, and we'll be looking at the sigma, and then the expression after the sigma is simply the explicit formula. The bottom of the sigma symbol is the lower limit. Usually it'll be 1, so we'll usually say I equals 1, and above that is the upper limit. So we have the sequence 8, 16, 24, up to 50 terms. If I look at that just quickly, the first term is 8, so a sub 1 is 8. The difference is also 8. So if I put this into my arithmetic sequence formula, I have a sub n equals a sub 1 plus n minus 1 times the common difference. I'll have 8 plus the quantity a minus 1 times 8. Simplifying that, I end up with a sub n equals 8n. That is my explicit formula. So I'll just put that into my sigma notation. I'll have n equals 1 as my lower limit, 50 as my upper limit, and my explicit notation 8n. Alright, now you guys try check understanding 3, use the summation notation to write the series and the specific number of terms. So go ahead, I'll give you a moment and complete that, and then we'll check. Alright, you've had a little time to look that over. So our sequence is a sub n equals a sub 1 plus quantity n minus 1 times the common difference. If I put those values in, the first term is 1, the common difference is 1, and I simplify that, I simply get n. So my summation notation is the sum of n from I equals 1 to 6. And I have a small mistake there. That should be not an I, but an n. So I'll see if I can make that change. That should be an n there, n equals 1. The second one, the first term is 3, the common difference is 5, so again I'll put it into my sequence formula, and I end up with 5n minus 2. As a summation notation, I have the sum from 1 to 9, n equals 1, from 5n minus 2. Example 4 says use the series, the sum of negative 2n plus 3 from 1 to 4. So I'm just going to write it out, negative 2, then I put the 1, because that's my first term, I'm going to put in there, plus 3. And then I'm going to go up the succeeding numbers, 2, 3, and 4, and just put them in 4n. I will simplify them, so the first group I get a 1, the second group a negative 1, the third negative 3, and the last one is negative 5. Add them up, I get a negative 8. So the sum of that series is negative 8. Another way we could have looked at this was to simply find the sum of the first 4 terms, so that would be by formula s sub 4 equals n over 2, which in this case is 4 because I have 4 terms, times the first term plus the last term, and if I simplify that, I again get negative 8. So we can work it out long or use a shortcut with the formula. Now go ahead, probably with the formula, because that would be most efficient. Solve the next 3 check understanding problems. The first problem, the sum of n minus 3 from 1 to 10. N is 10, so I put that into my formula. The first term is negative 2. The last term is positive 7. If I put a 10 in for n, 10 minus 3 is 7. If I simplify this, I get 25. The sum of that expression from 1 to 10 is 25. Looking at the second one, my first term, I'm going to find the sum of the first 4 terms, so I'll have 4 over 2. My first term is 1.5, or I'm sorry, the first term is 3 halves, 1.5, plus the last term is 3. If I add that up, I'll get the summation of the number 9. The last one, I'm wanting to go from 2 through 5. So I'm going to start at n equals 2, and I'm going to go up through the number 5 for the sequence of terms of n squared. So when I look at this, I have 4 terms that I'm going to be summing, 2, 3, 4, and 5. So I'm running out of time here, so I'll just sketch it out really quick. S sub 4 equals 4 over 2, n is 4. The first term is 4 plus 25, the last term. Simplifying it, 2 times 29, and I get 58. 58 is the sum of that sequence for n squared. That's all for this lesson. If you have any questions, we can handle that in class tomorrow.